At exactly 15 billion miles away from the warmth of our star, there is a piece of human machinery flying completely blind through an ocean of violent plasma. It operates on roughly 20 watts of power, less than a standard refrigerator light bulb. It is freezing, it is degrading, and it is entirely alone. This is Voyager 1, and right now, it is doing something that has deeply unsettled the engineers at the Jet Propulsion Laboratory. It is sending back a pulse, a continuous string of telemetry data that simply makes no sense. For over 4 decades, human intuition painted the edge of our solar system as a quiet, fading frontier. We modeled the heliopause as a gentle boundary, a peaceful transition from the protective magnetic bubble of the solar wind straight into the calm, empty void of interstellar space. But the data trickling in from the dark is tearing those theories apart. Every single piece of information from Voyager takes over 22 hours to reach us, traveling at the absolute maximum speed limit of the universe, the speed of light. The signal is broadcast from a decaying transmitter, fighting against the immense background noise of the entire Milky Way galaxy. By the time this signal washes over the massive dish antennas of the Deep Space Network here on Earth, its strength is roughly 1/billionth of a single watt. We are, quite literally, listening to a ghost, and this ghost is speaking in riddles. The void beyond our sun is not empty, and it is far from peaceful. It is a crushing, chaotic wall of cosmic radiation and magnetic turbulence. Somewhere in that abyss, Voyager 1 began transmitting impossible readouts about its own internal status. The telemetry suggests that its attitude control system is registering movements that never happened. The physical antenna remains perfectly locked onto Earth, meaning the spacecraft is physically stable. Yet the ancient onboard computers are screaming that they are trapped in a chaotic, impossible geometry. It is as if a deep-sea probe, designed to measure calm waters, suddenly began sending back data from the middle of a raging underwater fire. We sent a machine out into the dark to map the absolute frontier of our reality. Instead, it hit a wall of static, and the machine started hallucinating. Or worse, it started measuring the exact, terrifying reality of the interstellar medium that our clean mathematical models failed to predict. The boundary of our solar system is not a quiet exit door. It is a violent shield, and we have finally pushed something through it, only to realize we do not understand what is waiting on the other side. If you seek the truth in the dark, subscribe and join us on this journey. To truly understand the nightmare that Voyager is currently navigating, we have to dismantle the greatest lie you were ever taught about space. If you ask the average person to picture the cosmos, they will imagine a silent, empty canvas, a perfect, pristine vacuum where the planets hang suspended in a cold, absolute nothingness. We are conditioned by centuries of simple diagrams and clean textbook illustrations to view the space between worlds as an inert void, a quiet, dark room where absolutely nothing happens. This intuition is not just slightly incorrect, it is completely, dangerously wrong. Space is not an empty room. It is a raging, invisible weather system. It is a chaotic, electrical ocean governed by forces so massive they crush our terrestrial understanding of physics. And the entity responsible for this violent weather is our own sun. For a long time, early astronomers believed the sun was simply a celestial light bulb, a massive sphere of burning gas that radiated light and heat, but nothing more. They believed its influence ended where the light faded. But in the mid-20th century, the mathematics began to whisper a different, far more aggressive story. In the year 1958, a young astrophysicist named Eugene Parker presented a mathematical model that was considered absolute heresy by the scientific establishment. Parker looked at the intense, boiling outer atmosphere of the Sun, known as the corona. The temperature of the corona is not measured in thousands of degrees, but in millions. Parker's calculations showed that this extreme heat should cause the Sun's atmosphere to expand violently outward. The gravity of the star simply could not hold on to it. He proposed that the Sun was constantly vomiting millions of tons of superheated material into the void every single second. This was not a gentle emanation. This was a continuous, explosive blast of plasma, a stream of naked protons and electrons, carrying the Sun's own magnetic field out into the darkness at speeds exceeding 1 million miles per hour. He called it the solar wind. When Parker submitted his paper to the leading astrophysical journal of the time, the peer reviewers universally rejected it. They told him his physics were flawed. They told him that space was a vacuum, and that a wind blowing through the void was a physical absurdity. It took the intervention of one of the greatest physicists of the era to force the paper into publication. And within a few short years, the first interplanetary probes proved that Parker was absolutely right. The wind was real. It was hitting the Earth. It was washing over Mars, and it was screaming out into the deep dark. This discovery fundamentally changed our understanding of our place in the universe. We were not floating in an empty void. We were submerged inside a colossal, expanding bubble of solar plasma. Imagine a single campfire burning in the middle of a massive, freezing, storm-swept forest. The fire provides heat and light, but it also produces a constant stream of smoke that pushes back the cold air of the surrounding woods. This invisible bubble of smoke, fighting against the crushing pressure of the forest, is the perfect analogy for our solar system. We call this protective magnetic bubble the heliosphere. Inside the heliosphere, the solar wind dictates the rules of physics. It acts as an invisible shield, deflecting the vast majority of the lethal cosmic radiation that drifts through the galaxy. Every planet, every moon, every asteroid we have ever observed exists safely within this bubble. It is our entire known world. But a bubble, by its very definition, must have an edge. Astrophysicists knew that the solar wind could not travel outward forever. The galaxy is not empty. The space between the stars is filled with the interstellar medium. This is the graveyard of the Milky Way. It is a dense, freezing smog composed of the shattered remains of ancient supernovas, the corpses of dead stars, wandering rogue planets, and massive clouds of cold hydrogen gas. This galactic smog exerts a colossal, crushing pressure of its own. Eventually, the outward push of the solar wind must collide with the inward crush of the interstellar medium. The point where these two titanic forces meet, where the Sun's influence finally surrenders to the weight of the galaxy, is known as the heliopause. For decades, the heliopause was nothing more than a ghost in the mathematics. It was an abstract concept. We had no idea exactly how far away it was, and we had absolutely no idea what it actually looked like. The prevailing theory, born from the same clean intuition that imagined space as an empty room, was that the boundary would be smooth. We modeled the heliopause like a gentle river flowing into a vast, quiet lake. We assumed the solar wind would gradually slow down, its magnetic field peacefully dissolving into the calm, empty void of interstellar space. It was a beautiful, elegant theory, and it remained unchallenged because humanity possessed nothing capable of reaching that distance to prove it wrong, until the late summer of 1977, when the engineers at the Jet Propulsion Laboratory launched Voyager 1. They were not thinking about the interstellar medium. The spacecraft was built for a 5-year mission to photograph Jupiter and Saturn. That was its primary directive. Everything else was a theoretical bonus. To understand the sheer audacity of this machine, you have to strip away your modern understanding of technology. Voyager does not have a gigabyte of memory. It does not even have a megabyte. Its entire onboard computer system operates on roughly 68 kilobytes of memory. That is less computing power than the microchip inside a modern electronic car key. Its scientific data is not stored on solid-state drives. It is recorded onto physical, moving magnetic tape using primitive 8-track tape recorders that must constantly rewind and fast-forward in the freezing dark. The spacecraft is powered by a radioisotope thermoelectric generator, a decaying pellet of plutonium-238 that generates heat as it slowly dies. Every single year, the spacecraft loses about 4 watts of electrical power. The engineers are constantly forced to play a desperate game of survival, shutting down heaters and turning off scientific instruments just to keep the vital organs of the probe from freezing solid. This is the machine we sent into the abyss, a fragile, freezing relic of the 1970s, hurtling away from the sun at over 38,000 miles per hour. After it completed its planetary flybys, Voyager did not stop. It kept falling upward, deeper into the dark, riding the relentless wave of the solar wind. Years turned into decades. The sun shrank from a blinding, life-giving orb into a terrifyingly distant, cold star. The light faded, the temperature plunged toward absolute zero, and as the new millennium approached, the instruments on Voyager began to detect a subtle, terrifying shift in the environment. The solar wind, which had been rushing past the spacecraft at a constant, supersonic speed for decades, suddenly began to die down. It was piling up, compressing, heating up. Voyager was hitting the termination shock, the first sign that the gentle river of the solar wind was not flowing into a calm lake. It was violently crashing against a brick wall. The models were unraveling. The clean, mathematical gradient we expected was nowhere to be found. Instead, the ancient sensors on the probe began to register spikes in magnetic turbulence. The plasma was twisting, contorting, and folding back on itself. The machine was entirely alone, 15 billion miles from its creators, slowly bleeding power, and it was approaching the edge of the map, and the map was wrong. To grasp the absolute terror of the anomaly that is currently unfolding, we must first measure the sheer, incomprehensible scale of the crime scene. Humanity throws the word billion around with dangerous casualness. We use it for populations, for currencies, for data storage, but when applied to the physical distance of the cosmos, the human brain simply collapses. It is not built to process the void. Voyager 1 is currently over 15 billion miles away from the Earth. If you were to fire a high-powered rifle in a straight line, and the bullet never slowed down, it would take that bullet over 1,800 years of continuous travel to reach the spacecraft's current location. At this distance, the sun is no longer a massive, blinding sphere of fire. It has been reduced to a single, intensely bright star in a sea of absolute black. It offers no discernible heat. The ambient temperature surrounding the titanium hull of the probe hovers at roughly -450 degrees Fahrenheit. This is just a few degrees above absolute zero. the theoretical limit where all atomic motion stops entirely. Yet, across this terrifying ocean of nothingness, we maintain a tether to hear the faint, dying whispers of Voyager. The National Aeronautics and Space Administration relies on a global infrastructure known as the Deep Space Network. These are not standard satellite dishes. These are colossal, 70-meter-wide parabolic antennas weighing millions of pounds, stationed in California, Spain, and Australia. As the Earth rotates, these massive mechanical titans hand off the tracking responsibilities to one another, ensuring that at least one electronic ear is always pointed toward the outer dark. The signal they are trying to catch is unfathomably weak. By the time the radio waves from Voyager crossed 15 billion miles of expanding space, they hit the Earth with a power level of roughly 1/20 billionth of a single watt. It is a signal so fragile that the ambient thermal radiation of the Earth itself threatens to drown it out. To compensate, the receivers on the deep space antennas are submerged in liquid helium, freezing the electronics to eliminate the microscopic noise of vibrating atoms. We go to these extreme, almost absurd engineering lengths just to receive a data stream moving at a pathetic 160 bits per second, a speed so slow it would take days to download a single photograph. But Voyager is no longer sending photographs. Its cameras were permanently shut down decades ago to save power. It is only sending cold, hard numbers, telemetry, magnetic field readings, plasma density counts. It is sending the weather report from the abyss. To understand the weather at the edge of the world, you must understand the instruments measuring it. Voyager relies heavily on two specific pieces of ancient technology. The first is the magnetometer. It is essentially an extremely sensitive compass, mounted at the end of a long, frail boom, far away from the electromagnetic interference of the spacecraft's own computer. Its job is to measure the strength and the direction of the invisible magnetic fields twisting through space. The second crucial instrument is the cosmic ray subsystem. This is not a camera. It is a cluster of solid-state detectors designed to catch the most dangerous, high-energy particles in the universe. We call them galactic cosmic rays, but the name is dangerously deceptive. They are not rays of light. They are physical shrapnel. They are the naked cores of atoms, stripped of their electrons, and accelerated to 99% the speed of light by the cataclysmic explosions of dying stars. Supernova. These particles are the ultimate threat of deep space. They carry so much kinetic energy that if a single heavy cosmic ray strikes a microscopic transistor inside a computer, it can flip a binary 0 to a 1, corrupting data and crashing systems. If they strike a human cell, they shatter the DNA like a bullet hitting glass. The only reason life can exist on Earth, the only reason our atmosphere has not been stripped away, is because the heliosphere, the massive magnetic bubble generated by our Sun, deflects the vast majority of these galactic bullets. For 35 years, Voyager flew safely inside this bubble. The cosmic ray subsystem registered a low, manageable hum of background radiation. The magnetometer recorded the steady, outward-flowing magnetic field of the Sun. But as the calendar turned to the year 2010, the data began to stutter. Voyager had entered an area astrophysicists came to call the stagnation region, the constant, supersonic gale of the solar wind, which had been blowing past the spacecraft for 3 decades, suddenly began to die down. Imagine floating down a fast-moving river, and suddenly the water around you stops flowing forward. It just begins to swirl. It begins to compress. The raw data trickling into the deep space network showed that the outward velocity of the solar wind had dropped to zero. The plasma was piling up, heating up under the immense pressure of the galaxy pushing back. The tension inside the Jet Propulsion Laboratory was palpable. The scientists knew the spacecraft was approaching the ultimate boundary, the heliopause, but they expected a smooth crossing. They expected the mathematical models to be vindicated. They expected the solar particles to slowly fade out and the galactic cosmic rays to slowly fade in, a gentle blending of two environments. Instead, on August 25, 2012, Voyager hit a wall. The transition was not a gradual fade, it was a violent, structural shear. Over the course of just a few days, the count of solar particles hitting the detectors plummeted by a factor of 1,000. It was as if someone had slammed a massive steel door shut. Simultaneously, the cosmic ray subsystem began to scream. The counts of lethal high-energy galactic cosmic rays spiked to the highest levels ever recorded in human history. The spacecraft had broken through the shield. It was now fully exposed to the raw, unfiltered radiation of the Milky Way galaxy. Humanity had officially left the solar system. The press releases were triumphant. The headlines celebrated the historic achievement. But deep inside the data processing centers, the astrophysicists were not celebrating. They were staring at the readings from the magnetometer in a state of absolute, terrified confusion. Something was deeply, fundamentally wrong with the boundary. According to every established law of physics, crossing the heliopause should have triggered a massive shift in the magnetic field. The magnetic field of the Sun, which originates from our star, and the magnetic field of the interstellar medium, which is generated by the galaxy itself, should not point in the same direction. They are created by entirely different forces, separated by trillions of miles. When Voyager crossed the boundary, the magnetometer should have registered a sharp, dramatic change in the angle of the magnetic field lines. It should have clearly indicated that the spacecraft was now flying through a different magnetic ocean, but it did not. The intensity of the magnetic field spiked, proving the spacecraft had indeed hit a high-pressure wall. But the direction of the magnetic field did not change at all. It remained perfectly, impossibly aligned with the magnetic field of the Sun. The scientists dubbed this anomaly the magnetic highway. The data suggested that the boundary of our solar system was not a closed bubble. It was fractured. The magnetic field lines of the Sun had somehow connected directly to the magnetic field lines of interstellar space, creating massive, invisible conduits that allowed solar material to leak out and galactic radiation to pour directly in. This single piece of telemetry broke decades of theoretical modeling. It meant the heliopause was not a smooth surface. It was a complex, tangled, unstable mesh of terrifying magnetic energy. Desperate for answers, scientists turned to an instrument much closer to home. In the year 2008, the National Aeronautics and Space Administration launched a satellite called the Interstellar Boundary Explorer into orbit around the Earth. Its mission was not to fly to the edge, but to map it from afar, because the heliopause is completely invisible to optical telescopes. This satellite was designed to detect something called energetic neutral atoms. These are rare particles created in the extreme violence of the boundary when the hot solar wind collides with the freezing interstellar gas. By catching these particles as they drifted back toward Earth, the satellite could paint a rough thermal picture of the entire edge of the solar system. The mapping process took months, but when the first complete image of the heliosphere was finally compiled, and displayed on the monitors, it sent a shockwave through the scientific community. The image did not show a uniform, predictable bubble. Instead, it revealed a massive, blindingly bright structure wrapping entirely around the solar system, a colossal, glowing band of intense energy and high pressure. They called it the ribbon. This ribbon was entirely unaccounted for in any theoretical model. It was a structure of pure, violent plasma physics, stretching across billions of miles of space, gripping the outside of our solar system like a glowing cosmic vice. The mathematical models were not just slightly off, they were blind to a fundamental mechanism of the universe. The data from the Interstellar Boundary Explorer, combined with the impossible magnetic readings from Voyager 1, painted a horrifying new picture of our reality. The interstellar medium was not a quiet, empty sea, and our heliosphere was not a peaceful ship sailing through it. We are a high-pressure submarine, navigating through a boiling, chaotic storm of crushing magnetic forces. The boundary of our world is buckling, twisting, and snapping under the weight of the galaxy. And out there, deep inside that violently unstable transition zone, 15 billion miles from the engineers who built it, Voyager 1 continues to fly. It is a machine running on a dying nuclear heart, navigating an environment it was never designed to survive, measuring forces that defy human mathematics. For years, it sent back this anomalous, terrifying data, forcing scientists to rewrite the textbooks on plasma physics. But the magnetic highway was just the beginning, because recently, the cold, steady stream of bizarre scientific data stopped. The spacecraft did not go silent. The radio signal is still broadcasting. The deep space antennas are still receiving a pulse, but the binary code arriving on Earth has mutated. The telemetry that describes the health, the orientation, and the physical reality of the spacecraft has devolved into a repeating, impossible pattern. The machine is speaking, but its words are those of a mechanical mind that has completely lost its grip on physical reality. It is sending us data that suggests it is simultaneously everywhere and nowhere, that its internal systems are functioning perfectly, while entirely disregarding the physical laws of orientation in three-dimensional space. We are tracking a ghost ship, broadcasting from the edge of the abyss. To comprehend the absolute nightmare that began unfolding in the middle of the year 2022, we must first dissect the mind of the machine itself. In the absolute void of deep space, human concepts like up, down, left, and right cease to exist. There is no horizon to ground you. There is no atmosphere to provide aerodynamic stability. If an object is left alone in the vacuum, even the slightest microscopic imbalance will eventually cause it to tumble. For a deep space probe, tumbling is a death sentence. To survive, Voyager 1 is equipped with a mechanical brain known as the Attitude Articulation and Control System. This system has one single, unforgiving purpose. It must keep the massive, 3.7-meter-wide parabolic high-gain antenna pointed precisely down to a fraction of a single degree directly at the Earth. If the antenna drifts off target, the radio beam will miss our planet entirely. It will sweep harmlessly across the empty dark of the solar system, and Voyager will be lost to us forever. The tether will be cut. To maintain this flawless orientation over a distance of 15 billion miles, the Attitude Articulation and Control System relies on a method of celestial navigation that is as ancient as seafaring, executed with cold, robotic precision. When the spacecraft launched in the year 1977, it locked its optical sensors onto two fixed reference points. The first was the Sun. The second was a distant, incredibly bright star known as Canopus. By constantly measuring the exact angle between the blinding light of our local star and the distant light of Canopus, the onboard computer can calculate its exact orientation in three-dimensional space. It is a flawless mathematical lock. Whenever the spacecraft begins to drift, even by a millimeter, the computer detects the microscopic shift in the starlight. It immediately sends an electrical command to a network of tiny propulsion thrusters mounted along the titanium frame. These thrusters do not fire massive plumes of fire. They emit incredibly short, precise bursts of hydrazine gas, sometimes lasting only 10 milliseconds. These microscopic puffs of gas provide just enough physical thrust to nudge the spacecraft back into perfect alignment. For over 4 decades, this intricate, mechanical ballet worked flawlessly. The thrusters fired, the star tracker held its lock, and the antenna remained perfectly aligned with the Earth, sending back the priceless telemetry that rewrote our understanding of the solar system. But then, the data began to rot. Deep inside the data processing centers at the Jet Propulsion Laboratory, engineers monitor the health of the spacecraft through a continuous stream of binary code known as telemetry. This is the heartbeat of the machine. It tells the engineers the temperature of the plutonium power source, the pressure of the hydrazine fuel tanks, and the exact status of the attitude, articulation, and control system. Without warning, the telemetry data generated by the attitude control system mutated into something entirely impossible. The computer was not sending back static, which would indicate a simple failure or a loss of signal. Static is predictable. Static is normal. Instead, the ancient computer began transmitting highly structured, randomly generated junk. The binary code suggested that the spacecraft was in a state of absolute mechanical chaos. The numbers indicated that the gyroscopes were failing, that the memory banks were filled with nonsensical values, and that the orientation of the spacecraft was completely broken. According to the data arriving on Earth, Voyager 1 was tumbling wildly out of control, lost in the dark, spinning wildly through the interstellar medium. But this is where the paradox emerges, a paradox that defies every logical rule of aerospace engineering. If the telemetry data were accurate, if the spacecraft were truly tumbling, the high-gain antenna would be thrown violently off target. The signal arriving at the massive dishes of the deep space network here on Earth would have vanished instantly. But it did not. The radio signal remained absolutely perfect. The carrier wave was rock solid. The data transmission rate did not drop by a single fraction of a percent. The physical reality of the spacecraft entirely contradicted the digital reality of its internal computers. The antenna was still locked directly onto Earth, meaning the mechanical hardware, the sensors, and the thrusters were still operating flawlessly. The spacecraft was physically stable, yet the electronic brain responsible for orchestrating that stability was screaming that it was completely broken. It was an impossible contradiction. A machine functioning perfectly while entirely convinced it was dying. Imagine a massive, complex grandfather clock. The pendulum is swinging with perfect, rhythmic precision. The hands are moving across the dial, telling the exact time. You can hear the steady, mechanical heartbeat of the gears. But when you open the wooden cabinet to look at the intricate machinery inside, the gears are not where they are supposed to be. The cogs are spinning in reverse, the springs are unspooled, and the internal mechanics resemble a shattered puzzle. Yet, the clock continues to keep perfect time. That is the paradox the engineers were forced to confront. To solve this terrifying mystery, the team at the National Aeronautics and Space Administration had to initiate a debugging process across an unimaginably hostile void. This is not like troubleshooting a server on Earth. We live in an era where global communication is virtually instantaneous. We expect an immediate response when we hit a key. We are blind to the physical infrastructure of our own digital world. But to communicate with Voyager 1, you must submit to the absolute, unforgiving, physical limits of the universe. You must submit to the speed of light. Radio waves, like all forms of electromagnetic radiation, travel at a speed of roughly 186,000 miles per second in the vacuum of space. This is the absolute maximum speed limit of reality. Nothing can go faster. At a distance of 15 billion miles, it takes a single radio command precisely 22 hours and 30 minutes to cross the vast, freezing ocean of the solar system and reach the spacecraft. Imagine the sheer latency of this operation. An engineer in a control room in California types a command into a modern terminal. That command is translated into the archaic binary language of the 1970s. It is then routed to one of the colossal, 70-meter-wide parabolic antennas of the Deep Space Network. The dish unleashes a massive, focused pulse of radio energy, beaming thousands of watts of power directly into the sky. The invisible wave of information races past the orbit of the Moon in just over 1 second. It flashes past the rust-colored deserts of Mars in a matter of minutes. It takes hours to cross the asteroid belt and sweep past the swirling gas giant of Jupiter. It flies past the icy rings of Saturn, past Uranus, past Neptune, pushing deeper and deeper into the dark. Long after the light of the sun has faded into a single, cold point in the blackness. Almost a full day after it was transmitted, that wave, now decayed to a microscopic whisper of its original strength, washes over the freezing titanium hull of Voyager 1. The ancient computer receives the command. It processes the instructions with a processor that runs thousands of times slower than a modern digital watch. It executes the code, compiles a response, and fires its own weak, incredibly faint radio signal back toward the inner solar system. That faint pulse must then travel for another 22 hours and 30 minutes, fighting against the background radiation of the entire Milky Way galaxy, before it finally hits the massive listening dishes on Earth. A single ping requires a staggering 45-hour round trip. Imagine trying to drive a high-speed vehicle through a dense, zero-visibility fog, but your steering wheel only responds to your physical inputs to entire days after you turn it. That is the terrifying latency of interstellar engineering. Under these crushing constraints, the engineers had to diagnose a software failure in a machine they could not see, touch, or restart. Sending a simple reboot command was considered a massive, potentially fatal risk. If the ancient computers failed to wake up from the reboot sequence, the spacecraft would be bricked. It would become a silent, dead piece of space debris instantly. Instead, they had to dig into the past. The team was forced to unearth archived, decades-old technical manuals. Documents that were originally typewritten on yellowing paper, containing the handwritten notes of engineers who have long since retired or passed away. They had to mentally reverse engineer the architecture of a computer system built with only a few kilobytes of volatile memory. After months of agonizing slow-motion forensic investigation across the solar system, they found the culprit. The attitude, articulation, and control system was not broken. It had simply started routing its vital telemetry data through an archaic onboard computer module that was known to have failed years ago. It was a digital glitch, a ghost in the machine, a routing error that caused good data to be corrupted by a dead processor before it was transmitted to Earth. The engineers carefully constructed a highly specific string of binary code, a delicate command instructing the system to switch its data stream back to the correct, functioning module. They beamed the command into the void. They waited the agonizing 45 hours, and the fix worked. The telemetry returned to normal. The numbers made sense again. But the victory was cold, and the relief was entirely short-lived, because while the engineers had solved the how of the anomaly, they were left staring into the terrifying void of the why. Why did a spacecraft, which had been executing perfectly stable code for 45 years, suddenly decide to switch its data routing to a dead computer? Computers do not change their fundamental operating logic without an external physical trigger. A memory bit does not flip itself. It requires energy. It requires an impact. This forces us to confront the most unsettling realization of the entire mission, the fundamental, theoretical breakdown that is currently keeping astrophysicists awake at night. The interstellar medium is not a passive environment. It is actively attacking the machine. For decades, the theoretical models of the cosmos dictated that once a spacecraft pushed through the turbulent boundary of the heliopause and entered interstellar space, the environment would calm down. We believed the void between the stars was empty, static, and peaceful. We expected the density of plasma and matter to drop significantly as we moved further away from the influence of the ENSO. But the instruments on Voyager 1 are telling a wildly different story. Instead of decreasing, the density of the cold plasma in interstellar space is actually increasing. The spacecraft is equipped with an instrument designed to measure plasma waves. Because the plasma in deep space is incredibly diffuse, it does not behave like a normal gas. It is a highly conductive sea of charged particles, electrons, and naked atomic nuclei. When shock waves from distant solar flares or coronal mass ejections finally crash through the boundary of the heliosphere, they ripple out into this interstellar plasma, causing the electrons to oscillate and vibrate. The instruments on Voyager capture these oscillations and translate them into a frequency that can be measured. It is, quite literally, the sound of the interstellar void. By measuring the pitch and frequency of these plasma waves, physicists can calculate the exact density of the invisible medium the spacecraft is flying through. When Voyager first crossed the heliopause in the year 2012, the plasma density was measured at roughly 0.039 electrons per cubic centimeter. But as the probe pushed deeper into the dark, covering hundreds of millions of miles of new territory, the density did not drop. It rose. By the year 2013, it had climbed to 0.055. By the year 2015, it reached 0.074, and the most recent data indicates the plasma density has climbed to over 0.12 electrons per cubic centimeter. The numbers seem small, but the mathematical implication is absolutely terrifying. The density of the interstellar medium is compressing. It is thickening. Voyager is not sailing out into an open, empty ocean. It is flying directly into a massive, invisible wall. Our clean, pristine models of the galaxy completely failed to predict this compression. We are only now realizing that the heliosphere, the magnetic bubble protecting our entire solar system, is plowing through a dense, highly magnetized cloud of ancient cosmic material. Astrophysicists call it the Local Interstellar Cloud. It is a massive structure of gas, dust, and dark matter spanning nearly 30 light-years across. As our entire solar system orbits the center of the Milky Way galaxy, we are crashing through this cloud like a high-speed submarine moving through dense, muddy water. The increasing plasma density, measured by Voyager, is the bow shock. It is the physical buildup of material being crushed against the front of our solar system's magnetic shield. This incredibly dense, highly energized, and heavily irradiated environment is taking a brutal toll on the fragile, aging hardware of the spacecraft. The constant bombardment of high-energy galactic cosmic rays is physically degrading the microscopic transistors inside the memory banks. The dense, cold plasma is interacting with the decaying electrical grounding of the titanium hull. The anomaly in the attitude articulation and control system was not a random digital error. It was a symptom. It was a physical manifestation of a hostile environment actively breaking down the mechanical integrity of our technology. We sent a probe to map a quiet, empty frontier, only to discover that the frontier is a crushing, turbulent war zone of plasma physics. The theoretical models have broken down because human mathematics can only stretch as far as our physical observations. For centuries, our math was confined to the safe, warm bubble of the inner solar system. We assumed the laws of thermodynamics, plasma dynamics, and magnetic flow would smoothly extrapolate out into the deep dark. But the universe has no obligation to obey human intuition. We are blind in the dark, relying on a failing, freezing piece of machinery to feed us numbers that increasingly contradict our fundamental understanding of reality. And the machine is running out of time. The decaying plutonium power source is growing colder by the day. Soon, the engineers will be forced to make the ultimate, agonizing choices. They will have to systematically shut down the very scientific instruments that are unraveling this mystery, just to keep the vital heaters and the transmitter alive for a few more months. We are standing on the edge of the greatest physical paradigm shift in the history of astronomy, watching the data pour in from an impossible environment. But as the instruments degrade and the plasma thickens, a far more terrifying question emerges. If our models of the immediate interstellar medium are this profoundly flawed, what does that mean for the ultimate fate of our entire solar system? What exactly are we driving into? The question of what we are driving into forces us to abandon the comforting illusion that our solar system is a stationary sanctuary. When we look up at the night sky, the stars appear fixed. They seem like permanent, unchanging fixtures painted onto a black canvas. But this static view of the cosmos is the ultimate biological deception. Nothing is still. Everything is falling, spinning, and drifting at terrifying, incomprehensible velocities. Our sun is not anchored in place. It is currently dragging the Earth, the planets, and the entire protective bubble of the heliosphere through the Milky Way galaxy at a speed of nearly 500,000 miles per hour. We are on an endless, chaotic orbit around the supermassive black hole that anchors the center of our galaxy. A single journey around this galactic core takes roughly 225 million years. The last time our planet was in its current position in this cosmic orbit, the first dinosaurs were just beginning to evolve. For millions of years, the sun has been sailing through a relatively empty region of space, a quiet pocket in the galactic suburbs. But the anomalous data from Voyager 1 is the ultimate, undeniable proof that our quiet voyage is over. The increasing density of the plasma, measured by the ancient spacecraft, means we have crossed a threshold. We are driving our planetary system directly into a hostile, irradiated weather front. But the local interstellar cloud is only the immediate threat. The true horror lies in what this revelation means for our understanding of reality, time, and the ultimate, inescapable physical limits of human expansion. Because the consequences of a dense, violent interstellar medium destroy the greatest dream of modern civilization. The dream that we will one day leave this solar system and travel to the stars. Science fiction has conditioned us to believe that deep space is a frictionless vacuum, a vast, empty highway where a sufficiently advanced spacecraft could accelerate to a fraction of the speed of light, folding space or gliding effortlessly toward another star. We design theoretical propulsion systems from nuclear pulses to antimatter engines, assuming that the only obstacle is building a machine capable of going fast enough. The telemetry from the dark proves that this assumption is fundamentally, fatally flawed. Space is not a highway, it is a fluid, and when you move through a fluid at extreme velocities, you create friction, you create heat, you create a physical shockwave. If humanity were to build a generation ship, a massive vessel designed to carry human colonists to our closest neighboring star, Alpha Centauri, we would have to accelerate that ship to immense speeds just to make the journey in a single human lifetime. Let us assume we achieve the impossible. We build an engine capable of pushing a spacecraft to 20% of the speed of light. That is roughly 134 million miles per hour. In the quiet vacuum we thought existed, this would be a difficult but theoretical possibility. But in the dense, highly magnetized, plasma-rich environment that Voyager 1 has just discovered, traveling at that speed becomes a physical impossibility. At 20% the speed of light, the invisible interstellar medium stops being a passive gas. It becomes a microscopic weapon. Every single atom of stray hydrogen, every invisible electron, and every rogue proton floating in the dark would strike the hull of the spacecraft with the kinetic energy of a small explosive. At those velocities, the dust of the galaxy acts like a continuous storm of high-powered sniper fire. A single, microscopic grain of silicate dust, no larger than a grain of sand, striking a ship at 100 million miles per hour, would release the energy of a military-grade bomb. It would instantly vaporize the outer hull, sending a lethal shower of secondary radiation through the living quarters of the ship. The dense plasma wall that Voyager is currently navigating is not just a scientific curiosity, it is a quarantine zone. The boundary of the heliosphere is warning us that the universe has imposed a brutal, physical speed limit on our ambitions. We are trapped in our own protective bubble, and the ocean outside is entirely too violent for us to swim in. And this realization is compounded by an even more terrifying philosophical truth about the nature of time itself. Because we are not just separated from Voyager 1 by 15 billion miles of physical space, we are separated by time. When the massive deep space antennas on Earth receive a transmission from the probe, they are not hearing what the spacecraft is experiencing right now. They are receiving a snapshot of the past. It takes over 22 hours for a radio signal traveling at the absolute speed of light to cross the abyss. This means that if Voyager were to suddenly encounter a catastrophic failure, if it were to strike an invisible obstacle in the interstellar medium and be instantly annihilated, we would not know about it for almost an entire day. the scientists at the Jet Propulsion Laboratory would continue to look at their monitors, watching the steady, healthy pulse of a machine that had already ceased to exist. They would be analyzing the heartbeat of a ghost. In astrophysics, the concept of now is a localized illusion. There is no simultaneous reality in the universe. There is only the delayed, fragile information that manages to reach our instruments. We are trying to map the most dangerous, unstable boundary in our solar system through a 22-hour time machine. Every command we send is a guess. Every correction we attempt is an action taken in the dark, hoping the machine is still alive to receive it. And the machine is dying. The plutonium heart of Voyager 1 is not a perpetual motion machine. The radioactive decay of the plutonium-238 generates heat, which is converted into electricity by a piece of technology called a thermocouple. But the laws of thermodynamics are absolute, and they are unforgiving. Every single year, the radioactive material degrades. Every single year, the spacecraft loses 4 watts of vital electrical power. The engineers have spent the last 2 decades performing a desperate, slow-motion triage. To keep the transmitter alive, to keep the computer running, they have been systematically shutting down the very instruments that make the spacecraft scientifically valuable. They turned off the cameras in the year 1990. They shut down the planetary radio astronomy instrument in the year 2008. They disabled the ultraviolet spectrometer. One by one, the senses of the machine have been deliberately blinded, amputated in a desperate bid to extend its lifespan. The spacecraft is freezing. To save power, the internal heaters have been turned off. The ancient hydrazine fuel lines required to power the thrusters that keep the antenna pointed at Earth are hovering precariously close to their freezing point. If the fuel turns to solid ice, the thrusters will fail. The spacecraft will begin to tumble. The antenna will swing away from our planet, and the signal will be lost forever. But even if the fuel remains liquid, the mathematics of the power decay cannot be negotiated with. Sometime in the next few years, the electrical output will drop below the absolute minimum threshold required to power the main transmitter. When that day comes, there will be no explosion. There will be no dramatic final transmission. The massive 70-meter antennas on Earth will simply listen to the dark and hear nothing. The static of the Milky Way will wash over the frequency, drowning out the fragile pulse that has tethered us to the edge of reality for half a century. But the death of its electronic voice does not mean the spacecraft will stop moving. According to the laws of inertia, an object in motion will remain in motion unless acted upon by an outside force. Voyager 1 will continue to coast through the violently dense plasma of the interstellar medium at 38,000 miles per hour. It will fly on as a dead, silent tomb, a mechanical corpse carrying the golden record, a copper disc encoded with the sounds of our oceans, the music of our civilizations, and the anatomical blueprints of our bodies, a message in a bottle cast into an ocean that we now know is infinitely more hostile than we ever imagined. But perhaps the most terrifying hidden consequence of this entire mission is what Voyager still has to cross. Because while humanity celebrates the fact that the probe has left the solar system by crossing the magnetic boundary of the heliopause, the gravitational reality of our sun extends much, much further. The heliosphere is just the weather balloon of our star. The true gravitational anchor of the solar system is a theoretical structure known as the Oort cloud. It is a spherical shell of trillions of frozen comets, ancient ice, and dead planetary fragments that envelops our entire solar system. It is the debris field left over from the formation of our Sun 4.5 billion years ago. Voyager 1 is currently 15 billion miles away, but the inner edge of the Oort cloud does not even begin until roughly 185 billion miles away from the Sun, even traveling at 38,000 miles per hour. It will take the dead, silent spacecraft another 300 years just to reach the beginning of this icy graveyard, and it will take it another 30,000 years to cross it. The anomaly in the data, the crushing plasma, the magnetic highway, all of it is just the preamble. We have barely scratched the paint on the front door of our own cosmic house, and the environment has already broken our physics. We are isolated. We are surrounded by a violent, irradiated tide, and the single, fragile tether that connects our minds to the deep void is slowly fading into the static. We built massive observatories to look deep into the past. We convinced ourselves that if we just mastered the mathematics, we could master the void. We looked at the sheer scale of the cosmos and, in our profound arrogance, decided it was a frontier waiting to be conquered. But the dying signals of Voyager 1 have permanently shattered that illusion. It took 45 years for the most resilient piece of hardware ever constructed by human hands to reach the absolute limit of our own local environment. And instead of finding an open door, it hit a boiling wall of lethal plasma. The universe is not an empty, quiet canvas waiting for our arrival. It is a violently pressurized storm system, and we are marooned. We are trapped on a microscopic grain of rock and water, suspended inside a fragile, invisible magnetic bubble. A bubble that is currently buckling, twisting, and compressing under the sheer, crushing weight of a hostile galaxy. For centuries, we looked up at the night sky and felt a sense of profound, romantic invitation. We drew imaginary lines between the stars. We mapped celestial coordinates, and we wrote endless stories about building ships that would sail across the black ocean. We assumed the silence of deep space was peaceful, a quiet, empty highway stretching out toward infinity. But the cold, hard telemetry returning from 15 billion miles away has revealed the terrifying reality of our situation. The silence of the cosmos is not peaceful. It is the silence of an environment that is fundamentally incompatible with biology and actively hostile to our technology. It is a vacuum too vast for our voices to cross and too dense for our machines to survive. Voyager is the ultimate reflection of humanity itself. It is a fragile, freezing mechanism powered by a decaying nuclear heart, stumbling completely blind through an environment it does not understand. It is shouting strings of binary code into a hurricane of cosmic radiation, desperately trying to map a boundary that is actively tearing it apart. And the numbers it is sending back offer absolutely no comfort. We cannot negotiate with the laws of plasma physics. We cannot debate the kinetic energy of a galactic cosmic ray. Our most brilliant mathematical models, our supercomputers, and our colossal deep space tracking networks are nothing more than a thin, psychological layer of rationalization. They are tools we use to mask the terrifying, inescapable, physical trap of our own solar system. In a few short years, the final fraction of a watt will bleed out of the spacecraft's electrical system. The main transmitter will power down. The chaotic, anomalous telemetry will cease. The tether will snap, and Voyager will be swallowed by the dark, leaving us entirely blind to the shifting, violent weather of the interstellar medium. We will be left exactly where we have always been, trapped behind the boundary shock, drifting through a galactic void that does not know we exist, and does not care if we survive the crossing. The next time You stand outside, in the dead of night, and look up at the glittering expanse of the Milky Way. Do not look at the light of the stars. Look at the absolute blackness between them. That is not an empty void. It is a physical wall, and we are never getting through it.